Hello learners, I, Pallavi Joshi from Pune Institute of Computer Technology Pune welcome you all for the lecture series on OOP, which is nothing but object-oriented programming. In the last lectures, we have discussed programming paradigm like monolithic, procedural, structural and basic of OOP. Object-oriented programming is a programming paradigm that uses objects and their interaction to design application and a computer program. OOP is considered as a design methodology for building softwares. In object-oriented programming, every logic is written to get our work done, but represented in the form of objects. OOP allows us to break our problems into smaller units of work that is represented via objects and their functions. Here, we build functions around the objects. So in short, we can say an object-oriented programming language must support mechanism to define, create, store, manipulate object and allow communication between the objects. Let us learn the important features of object-oriented programming. So here on the screen you can see few features which includes classes, objects, method, message passing, inheritance, polymorphism, containership, reusability, delegation, data abstraction and encapsulation. Out of which classes and object are the basic building block of object-oriented programming. And these two features are our more important concern for this lecture. Among the rest of the features of OOP, these four are the basic pillars of object-oriented programming, which includes abstraction, inheritance, encapsulation, and polymorphism. Students, let us consider with an example explaining each of the pillar so you can better understand OOP. But before that, we need to know few basics of OOP. So including four pillars, rest of the features will be taken care in the coming lectures. So focus of today's lecture is classes and object. So to begin with, consider an example of a car. A car has a plan and other build information. So its template is fixed, having 4 wheels, steering wheel, 4 windows, engines, headlight, tail light, etc. Now, suppose any car manufacturer company take this plan. Say suppose Ford factory uses this plan and make a new car. A first car of any model is manufactured. We say it's a first instance or object of the car. A first object is created. So with this example, we can say a car, when considered as a class, it has a fixed template or a structure using which several objects can be created. So this makes a car an example of a class. Few more points related to class. A class is used to describe something in the world which is such as occurrences, things, external entities and so on. A class provides a template or a blueprint that describes structures and behavior of a set of similar objects. Once we have definition for a class, a specific instance of a class can be easily created. Class can be defined as a class represents a collection of objects having same characteristics, property that have common behavior. So we can conclude that a class is a blueprint of an object. For example, mango, apple, orange are all the members of a class fruit. In short, a class is an OOP. A class in an OOP is a plan which describes the object. We call it as a blueprint of how the object should be represented. Mainly, a class should consist of name, attribute and operation. So whenever we say we need to write a class, it must have attributes and operation. Name can be considered as a part of attribute. it can be explained with an example of, say, suppose a class mobile. So when we say class mobile, mobile must have an attribute and must have operations. So name can be considered inside an attribute. So mobiles can be of a number of companies, say iPhone, OnePlus, Samsung, Nokia, etc. Attributes of mobiles not limited to, but few are mentioned: IMEI number, processor, camera, etc. Operations not limited to, but few are mentioned: dialing, receiving a call, sending message, etc. So any class should have a fixed template related to attribute and an operation. With one more example of a class person, we say a person will have attributes like name, height, weight, color. Person will have the function or the method like walk, talk, sing, eat, dance, etc. If we take example of a class dog, then dog is a class which has attributes like breed of the dog, size of the dog, color of the dog, age of the dog, etc. Okay, now can you name the operations of class dog? Can you try to name? Yes, the operations can be: dog barks, so bark is an operation; dog walks, dog eat, dog sleep, etc. Okay, so the next is equally important concept of object oriented programming, an object, which we have unknowingly learned while learning a class. You remember I said in the example of car that when Ford manufactures its new car based on the template it had, it was the first instance. Here the instance is referred to our object. That is, instance of any class can be called as an object. Like a car company is not limited to only one car, a class is also not limited to only one object. An object is usually defined as an instance of class. In simple terms, it is an analogy to a pastry out of a mold. As long as same mold is used, one can create n number of pastries of same shape, isn't it? Yes. So in the same way, if you see around, you will find many objects like camera, monitor, laptop, table, pen, etc. These all are objects. If we take example of your class, say now your classroom should be the name of your class. So classroom has a table, bench, or tables, benches, board, fan, windows, door. Even students and teacher can be considered as an object of classroom, wherein every object has its associated attributes and operation. So a table will have separate attributes and their operation will be different to the attributes and operations of a person class, which will have students and teacher. So an object, once we have the definition of a class, a specific instance of a class can be easily created. A class can have multiple instances of an object. This we have discussed earlier. Figure shows that each class has its private data, which will be the attributes of a class, and methods or the functions. And the data and the method together, if we bind, that becomes an object of a class. Again we'll come to the same example of dog class. So when we say a dog is a class, then attributes of the dog we have discussed earlier, that breed or the size, shape, age of the dog are the attributes. Functions of the dog class are barking, eating, sleeping, running, etc. So here when I say dog 1 object, dog 2 object, dog 3 object, so this dog 1 object will have different name with this different values for the same attributes. Okay, so it may happen that when I'm saying dog 1, it's a Labrador dog, so the name is Labrador, its height will be different, its color will be different, its age will be different. If I say dog 2 is a bulldog, again the name is different, height, weight, size, shape will be different. German Shepherd, so is true for German Shepherd and Pug. So in short, object can be an entity which may represent a person, a place, a bank account, or any item that a program must handle. When a program is executed, the object interacts by sending message to another. If a customer and account are two objects in program, then the customer object may send message to account object requesting for the bank balance. This will be explained in more detail in one feature of object-oriented programming, that is message passing. So we can define an object like an object are the components of a program that know how to perform certain actions and how to interact with the elements of the program. An object can be something in the physical world or even just an abstract idea. An aeroplane, for example, is a physical object that can be manipulated by a computer. A simple figure which shows how to represent an object. So the name of this object is student. So student has attributes like name, date of birth, marks, and the functions total of the marks, average of the marks, display of the marks, etc. One more example showing a class student, wherein the attributes of class students are int roll number and string name. In Python, though we do not write the data type associated with the variable name, there is no harm in referencing in the example. Now, roll number and name are the attributes, and set roll number, display roll number, set name and display name are the operations or method of the class student. Now these methods and this attribute belongs to an object. So as you can see, we have created three objects of class student. First object, the roll number is set 1 and the name is set as Mary. So for Mary, I am setting the roll number, displaying the roll number, setting the name and displaying the name. The same is applicable to roll number 2, whose name is Ram, and roll number 3, whose name is John. More detail about the examples and execution of class and object will be explained in the coming lectures. As of now, we will stop after viewing how an object is created of a class. So syntax of creating an object are mentioned on this slide. In Python, there are two ways in which an object can be created. First, you write a class name space an object name. Second, a class name equals to object name with the parenthesis. To create an object of class fruit, we can write like this. So fruit, mango. So class name, object name. Second method, which is class name equal to object name and parenthesis, is a significant way in Python to create an object. So student, will stop here for the day. I hope the basic explanation, the very basic explanation of class and object is clear to all of you. This is not the complete explanation. We'll be coming up with more lectures explaining the classes, objects, and the other features of programming, object-oriented programming. In our syllabus, classes and objects are in more depth. So we'll be having the execution examples of classes and object in the coming lectures. Thank you for watching.